Hi everybody, so today we're focusing on finding the area of a triangle, but using trig to do this. So if we think of ways we already know how to find the area of a triangle, if we go back to the basics, we know that base times height all over 2. If this is your base and this is your perpendicular height all over 2, that is one way of finding the area of a triangle. And we met that in area and volume. The second way we met was when we came to coordinate geometry and say we were given a triangle on a coordinate grid like this and we're asked to find the area of it. So hopefully you remember that we have a formula for that in the log tables, and it is, so I don't have the log tables in front of me, but it was something like this. Say it was y2 times x1 plus x2 times y1. It was something like that, okay? And we would have said to ourselves, oh, well, if I was to label this point, and label this point, I would have x1, y1, x2, y2, x3, y3. And obviously in the formula, there is no x3 or y3. So what we had to do then was we had to move the triangle down to the point 0, 0, and that was how we did with the translation, and then we were able to use that formula. But today I'm going to focus on a third way to find the area of a triangle, and that's by using trigonometry. So the formula for this is given in our log tables, and what it is half AB sine C. Now, so you'll notice that obviously all of it is together, which means it's obviously all multiplied by. So I might write it a little bit neater. 1/2 AB sine C. And the second thing you might notice is that your A and B are small letters and your C is a large letter. And so I want to explain what that actually means first of all. Okay, so if I was given a triangle like so and I called all of the sides letters, when I'm putting notation on the sides of the triangle, I would use small letters. So say I might call that one A, this one B, and this one C. Then directly opposite each of those sides is the angle. So right here I'd have the angle C, here I'd have the angle A, capital A, and up here I'd have the angle B. Okay, so that's how we would label triangles always. And what we're asked to do now is find the area of a certain triangle. So AB sine C. So if we look at AB, our two lines here. So that's the side A, that's the side B. And sine C is actually the angle in between. Okay, so we always try, when you're looking to try and find using trig and finding the area of a triangle, you're going to take two sides and find the angle in between. And you can see there's your two sides, if I was to look at it like that, and that's the angle in between. And so, you know, that's essentially how we do this part of the question. So it's very easy, it's not too bad once you can understand what this means. So half AB sine C, the two small letters are the sides, and then the bigger letter is an angle. So like everything, we take an example, we apply the formula, and we probably will find out it's not too bad. So it's asked me to find the area of a given triangle. Now I say to myself, okay, well I know a few ways to find the area. The first is base times perpendicular height all over 2. In this question, I do have a base, but I do not have a perpendicular height. It's not a right angle triangle, as far as I can see, so I can't use Pythagoras and try and find out there, so that way is gone. The second way obviously is the coordinate grid, and obviously we don't have any points for any of these here, so that way is gone. So I am left then with the third way, which is the trig way, which is, I'm just going to get rid of that. So I'm left with my third way, which is half AB sine C. So the A and the B stand for sides and the C is an angle. And remember, it has to be the angle in between. So I'm going to refer to it as, there's the two sides and that's the angle in between. So it is half AB, so it doesn't matter which I call A and which I call B. Okay, so 6 by 8. Remember, they're stuck together here, so that means multiply. Sine, and again, that's all stuck together, so it's multiplied by the sine of 55 degrees. And all you're going to do there is you are going to type that into your calculator. You're going to make sure your calculator is in degree mode, so always that way for trig, and you should get 19.6596. And then it says to 2 decimal places. So you're focusing on these last 3 numbers. What's the next number you could bring that to? And it would be 600. So then it's 19.66. Okay. And then we don't know if we're obviously doing area, but we don't know if it's meters, if it's kilometers, if it's anything bigger than that. So we just say units squared. All right, example number 2, you could probably guess this is what was coming up next. It's where we're actually given the area and we have to work backwards and find an unknown. So in this case, we're told that one of the sides of the triangle is 10 centimetres, one of the other sides is 12 centimetres, and then the area is 25 centimetres squared. And we're actually asked to find the angle in between. So like everything, step 1, write down your formula. So we know area of a triangle, we're going to use the trig formula, is half AB sine C. And we know that the area of that triangle equals 25. So it's super important you're able to say, well, the area of the triangle equals 25. And, you know, technically we could write it above. Okay, so I have it written above. So we have area of a triangle equals 25. And then we replace the words with the formula. Okay, so step 1, write down your formula. Step 2, fill in what you know. So I know that I'm going to call this one A and this one B. And then this one here would be my sine C. So don't worry about the letters if they're not mixing up. We know what we're looking for. So I have half 10 by 12 by sine, and I'm going to call it X because we don't know what it is, equals 25. Now, with this here, I'm going to try and make that look a little bit nicer. So another way, instead of writing 1/2 10 by 12 by sine by X, hopefully you know it by now, but we can write it as 10 by 12 by sine X all over 2. And the reason why that is we can have the 1 up here and the 2 down here, and write the half like that. But obviously we know the 1 has no function in this case. So equals 25. And hopefully you'll spot then that obviously we're looking for sine of X. It's stuck in a fraction. So the best thing I can do here is I'm going to multiply both sides by 2 and get rid of the fraction. So they're going to cancel, and then up on top here I'm going to be left with 120 sine X equals 50. So that was my 25 by 2. And now I want to just get the X. So the first thing I'm going to get rid of is this 120, but it's obviously attached. So I'm going to divide both sides by 120. They cancel, and I'm going to get sine of X equals 5 over 12. And remember, I'm looking for X. I'm not looking for anything else. So I want to get rid of the sine. Okay, and the only way I can get rid of a sine is if I do sine to the minus 1, because that will actually cancel those two out. But remember, what I do to one side I must do to the other, so sine to the minus 1. So then I actually get in this question here, I get X equals sine to the minus 1 of 5 over 12. Okay, and then you're going to your calculator, you're making sure it's in degree mode, you're typing that in, and it's to the nearest degree if we look at the question. So we should be getting X equals 25 degrees. Okay, so you should be ready to do activity 4 now.